So if we're given a specific function, in this case, function happens to be a quadratic. We go back, we review the basic ideas for functions where we're taking some value of x. So in this case, I'm going to take 4, and I'm going to plug it into my function, right? F of 4, what does that mean? It means take 4, replace all the x's in the function with that value of 4. So up here, wherever I see an x, plug in 4. If I do that, I've got 3 times 4 squared plus 2 times 4 minus 11. So calculating that out. 4 squared, 16. 16 times 3 get 48. Add on 8 minus 11. So let's see, what's that come out to be? It comes out to be 56 minus 11, or 45. So the value of the function when x is 4 is equal to 45. Meaning also that if I graphed out this function, I looked at the points on the function, there would be an ordered pair somewhere where x is 4 and y is 45. Now, we focus our attention in on part B here, trying to find the actual value of x, where if we insert x in the function, we get -6 back. What that basically means is, all right, f of x, which is my y idea, if that's going to equal -6, go back here to the function where I have f of x, replace that with -6. Replacing with -6, we've got -6 equals 3x squared plus 2x minus 11. Okay, add your 6 over. We do that because if we're going to solve this quadratic form needs to be equal to 0. So I have 3x squared plus 2x. Adding 6 over, got minus 5 here. So now we consider the techniques that we have to solve a quadratic like this. Factoring, usually the first option. If that doesn't work, remember we fall back on the quadratic formula. So if we try to factor it, lead positions, we got 3x times x to give us that 3x squared. Ladder positions, got to multiply to give us 5. So 1 and 5, only factors that work. If we insert 5 here, 1 here, that should work out, right? Because if I make this a plus 5, got my positive 5x on the inside terms. If I make this a minus, that gives me a -3x on the outer term. So that combines back to give me that 2x. All right, so setting each of these factors now equal to 0. You've got 3x plus 5, set that equal to 0, right? If you solve that, subtract 5 over, divide by 3, x is going to equal -5/3. If I set x minus 1 equal to 0, solve that, I'd be adding 1 over, so x is 1. Got my 2 values of x in this case, where if I plug back into the function, apparently I'm going to get -6 back. So, part C here, kind of continuing our review, finding the x-intercepts. When we're finding x-intercepts, we have to set a certain value equal to 0 within the function, right? That certain value would be whatever corresponds to the y idea. So f of x corresponds to the y idea. I'm going to take f of x out. I'm going to put 0 in, because that means y would be 0 then. I'm going to set that equal to function 3x squared plus 2x minus 11. Okay, we discussed strategies here on how we're going to solve this quadratic. Since everything equals 0, we're set to go. We can try to factor it out, and if we can't factor it out, then we're going to use the quadratic formula, right? Is this one factorable? Doesn't appear to be. So let's review the quadratic formula. X is going to equal, well, let's see, it starts with -b. So b is 2, we say -2, plus or minus, square root of. Under the root, we've got the discriminant value of b squared minus 4ac. So b squared being 2 squared 4, minus 4 times a, which is 3, times c, which is negative 11. All over 2 times a is 3, so we'll say 6. I'm going to try to squeeze this in here. X equals negative 2 plus or minus square root of. Got to evaluate the discriminant. Let's see, in evaluating the discriminant, we've got negative 4 times 3, so that's going to be negative 12, times negative 11, that's going to be positive, what, 132, right? And then we're going to add on 4, so we get 136. Check my math there, a little early this morning. It's all over 6. Good. All right, we're looking at 136. Trying to break down 136. What's the largest perfect square that goes into 136? Okay, so if largest perfect square is 4, that goes into 136, and it goes in 34 times. We've got negative 2 plus or minus. Taking the square root of that 4, 2 pops out. Got a 34 left over under the root. That's all going to be over 6. And then the rule in reducing this any further was, as long as we had this value, and this value that shared common factors, we could divide the common factor out, right? But it was only this value right here that was outside the root where we could actually consider that, right? Value underneath the root, can't touch it. So if we take that common factor of 2 in this case out, you've got negative 1. Plus or minus, be 1 here, so it'd be 1 root 34, all over. Take 2 out of the 6, get 3 back. So find the x-intercepts. There's going to be 2 x-intercepts. Right, we know that because of the plus or minus here. It just turns out in this case that those intercepts are irrational values. Okay, so on this one, we're not actually asking you to find what x could be to equal these numbers. We're just trying to see, based on what we know about the discriminant, if it's possible we could get these solutions back. So we've got 2 values to consider here for the value of the function. F of x could equal negative 5, or f of x could equal negative 15. We're going to use what we know about the discriminant. Well, we're going to take our function, f of x being equal to the 3x squared plus the 2x minus 11 again. If the value of the function is going to be negative 5, well, let's set that equal to negative 5. And as common practice is on these types of problems, we're going to move that 5 over so everything equals 0. So add it over. Right? Whoa, that's not right. I misspelled my value here. If I add that over, it's going to be minus 6. But once again, we are not solving for x here. We're just trying to use the discriminant to see if this is ever going to be possible that the value of the function equals negative 5 in the first place. So, using our discriminant, which is b squared minus 4ac, plug in our corresponding values for a, b, and c here based on the form 3x squared plus 2x minus 6. So b is going to be 2, got 2 squared 4, minus 4 times a, which is 3, times c, which is negative 6. All right, if you calculate that out, let's see, you've got negative 4 times 3, negative 12. Negative 12 times negative 6, so that's going to be positive 72, right? Add 4. Discriminant's going to be 76. So using what I know about this discriminant value, is it possible that I could get a function value back of negative 5? Is it possible? You know? All right, as long as this is positive, then it's possible we could get negative 5 back. So, will it ever equal negative 5? The value of the function, will it ever equal negative 5? Yes, it's possible. So with that same sort of understanding, trying to look at the value of the function being equal to negative 15, start the same way. Take your function as 3x squared plus 2x minus 11, set it equal to negative 15. Setting everything equal to 0. Add 15 over. If I add 15 over, got plus 4 here, equals 0. Set up that discriminant, b squared minus 4ac. We've got 2 squared 4 minus 4 times a, which is 3, times c, which is 4. If I calculate out my discriminant, now let's see, negative 4 times 3, negative 12, times 4 is negative 48. This will be 4 minus 48, that's going to be negative 44. As we talked about on the previous one, if the discriminant value is positive, then yeah, it's possible to get that function value back. But if the discriminant value is negative, like this one is, then it is not going to be possible to find a value of x, where if we plug in here, we're going to get negative 15. So negative discriminant, nope, not going to happen. We know the value of this function will never be negative 15.